Fellas, before we dig into prime and composite numbers, quick bit of revision. We need to go over what factors are again. Let's remember, factors are just numbers that multiply together to give us a result. Remember, the answer of any form of multiplication is called a product as well. So in this number sentence, we can see here 2 multiplied by 4 is equal to 8. In this case, 2 and 4 would be considered factors because they've been multiplied together, and 8 is the answer, so 8 is considered the product. 2 and 4 would be factors of 8 because they multiply together to get us a result of 8. So by way of simple definitions, today we're looking at prime and composite numbers. Prime numbers are numbers that only have 2 factors, 1 and whatever the number is. Composite numbers, though, are numbers that have more than 2 factors. So a way to show that is, there's some examples here. Prime numbers can only have 2 factors. So for instance, we've got number 5 here, 2 numbers that multiply together to give us a result of 5, and that is 1 multiplied by 5. No other 2 numbers, no other 2 factors will multiply together to give us a result of 5. There's heaps of examples. Even if you just Google prime numbers, you can see the long list. The examples there are 5, 13, and even a number like 101. There's no 2 factors that multiply together to give you 101 other than 1 times 101. And composite numbers, well, they have heaps of factors. 9, for instance, has got 1 multiplied by 9 and 3 multiplied by 3. 24 has got 24 times 1, 12 times 2, 6 4s, 8 3s, lots of different combinations, more than 2 factors. A good way that you can use to visualize it is using a grid book or a simple grid square is to think about it. If you've got a number and then you're asked to think of all the factors, think about how many different ways you can lay that number out in tiles, so into rows and columns. So this visual demonstration here has done it with 12. So if you've got 12 pavers or 12 tiles you need to lie down, you could do 1 row of 12, you could do 2 rows of 6, or you could do 3 rows of 4. Now because there's a few different ways that you can do that, we would know that 12 is a composite number. If you've got tiles and you've got a number and there's only one way to put them, there's no even way to split them up into rows and columns, then you know you're working with a prime number. So even if you get a massive number, you can do a simple check using your grid book for something like that. Another way that you can visually demonstrate composite numbers is to do what's called a factor tree, which is what we're looking at here. That's when you start with a number, so let's say we're asked to list all the factors of 60, and then you just start breaking it down into factors as you go. So we know that 60 is the same as 6 multiplied by 10, and then you break down those factors even further. So I can break 6 down into, well, that's 2 multiplied by 3, and I can break 10 down into 5 multiplied by 2. It's pretty simple to do with almost any number too. If you're given one, you just break it down into the highest parts you can think of first. So for 24, I can think of, well, that's 6 multiplied by 4. Then I can break down 4 into 2 multiplied by 2, and I can break down 6 into 3 multiplied by 2. So it doesn't matter in the bottom line if you've got a repetition, if you've got more of the same number. It just helps you do what's called factorizing numbers. It was a strategy we looked at last year as well. Makes it easier to multiply larger numbers, and that's one extension problem you're going to have to face today. Breaking numbers down into smaller parts and using factorize to help you multiply them. So by way of a quick summary, remember prime numbers are numbers that only have 2 factors, 1 and themselves, and composite numbers are numbers that have more than 2 factors. They're the only 2 ways you need to divide numbers up into for this lesson, prime and composite numbers.